Okay, so we're going to be doing 3.2 Ready, Set, Go numbers 8 and 9. And the question, so it gives you this context and it says the distance from the shoreline of a fishing boat over time. And so one of the things that we've been working on is like looking at a graph and deciding like what this actually means. Some people see this as like the boat going in this much and then out and then in and out, and that's not correct. So this way is time. And this way is miles from the shore. So as time goes on, so time is going to continue regardless of what's happening. The boat is coming into shore, and then it goes out back to shore, back to the sea, and then back into the shore, back out, back in. Okay. And so I don't know what it's doing. It could be traveling along the coast, and it's getting closer to the coast, so that the people could see some of the sights on the shore. And it could be traveling far away because maybe there's, this is a beach here and they want to be safe. So they're traveling away at, minutes or hours 5, 6, 5, 6, and 7. They're traveling away and a little bit towards, they didn't want to get too close. And then, not like it's here, sorry, I meant time-wise here. And then it's going towards the shore again. Please don't think of this as a shore. That's what my point. So it says, during which part of the fishing trip was the boat most quickly approaching the shore? So wait, what? So which part of the trip, right, was the boat most quickly approaching the shore? So here they're saying how fast it's going. So if you notice here, it went from like 8 miles away to 1 mile away, and it took them 3 hours to do that, right? And then here, they went from 4 miles away to 2 miles away, and it took 2 hours to do that, right? And the last little bit, it took them 6 miles an hour. I mean, not 6 miles an hour, 6 miles away from the shore to 0 miles away from the shore. And that took, 12 to 64 hours. So which one is the fastest? And so if you understand what fast is, it's speed. And the way we measure speed is miles per hour. And miles per hour, miles over hours. It's kind of reminding me of slope. And in fact, it is slope. So they're asking for which one has the steepest slope going towards the shore, right? So here, this slope here, in case you don't remember, the slope of a function is going to be, the slope of a function is going to be rise over run. Sorry, I'm trying to find it here it is on my iPad. So if I look at this slope here, the rise is, I always start at the bottom one and I go to the top. I count how much that is. And we already figured out this is from 1 to 8. So this is 7 and this is 3 hours. So the slope of this line is 7 divided by 3. Okay. And then the slope of this line, I start with the lower one, go up and over. So that's 2 over 2. This is 1. My slope is 1 over 1. And the slope of this one is going to be 6 over 4. So this is 3 halves. So I'm trying to figure out which number is the greatest, like steepest. And so it turns out to be the number that's greatest. So just by eyeballing it, you can kind of be like, oh, I think this is the right one. And it actually is, because this is traveling. You can think about this as 2 1/3 miles per hour, while this is only 1.5 miles per hour. So the very first, the first part of the trip is the correct answer. Right? Because that's where they're traveling the fastest. They traveled the most over the shortest amount of time compared to this, right? This is 7 miles over 3 hours. This is 2 miles over 2 hours, or 6 miles over 4 hours. Okay. So this one is similar. It says the energy level of the tesseract over time in the latest science fiction movie. So I don't know what a tesseract is. I don't know. Maybe you guys do. I don't. It says the energy level of something over time. So here he has some energy and then he's losing energy and then maybe they charge him up. I don't know. Is this like a ship? Is this an animal? I have no idea. So then they charge it or they go to sleep and the rest is allowing them to have more energy. And then they're starting to even get more and more energy, right? So when is the change in the level increasing? When is the change in the energy level increasing? So whenever we talk about increasing, we're thinking about a roller coaster track and you're going up. So from here to here, we're going down. They're losing energy. So the energy level is decreasing. And then it starts increasing. And Ms. Johnson, is this increasing too? Because it's still going up. Yes. So the energy level is increasing starting at this number, which looks like it's 16. So I'm going to write a 16. And if you remember the notation that I've been wanting you to use, you put 16 and you put comma and you say, so here I can't tell where it's stopping, but it looks like it's right before 24. So I'm just going to pretend it continues to at least 24. Okay. And then so I'm going to put, now here's where people disagree. You could either put parentheses or brackets. I'm going to put brackets for today just because I want to show you it doesn't, you can do both. But in reality, the interval of increasing is from 16 through 24. So that's why we write it like this. So for this one here, they're asking you segments of increasing and decreasing, which brings us to the last problem, which is number 10. It says, consider the table of values that represents a continuous function. So hint, hint on the continuous function, right? Hint, hint. It says, which models the amount of water in the tank that supplies drinking water in the town. So based on the information in the table, determine the desired intervals and answer the questions, okay? So they're asking you where is it increasing? Where is it decreasing? What's the maximum? What's the minimum? And things like that. And so the first thing that I want to do is I want to look for the increasing intervals. So I'm going to look at my Y values to find out where the numbers are going up, up, up. And then I'm going to write the interval in terms of X. Does that make sense? I'm going to look at my Y values to figure out who's going up, up, up. And then I use my X values to create that information, like from when to when. So 24 moves up to 28, 28 moves up to 30, but then we go down to 22. So in this interval here, we are increasing. So I'm going to write from 0 to 2. Okay. I'm going to check the rest of it just to see if there's another interval of increasing. So that went down, it went down, it went down. Oh, we went up again. Up, up, up. So we went up from 5 to 8. So we went up from 5 to 8. Okay. And then we put a little U. Oops, sorry. I don't know why that little line appeared, but then we put a little U right here. And the little U means I want this section and this section because both of those are intervals of increasing together, right? So from here to here, and you can think about it like that, from here to here. So similarly, decreasing is when it's going down, and we already talked about it. It decreases from here, decreases, and decreases. So we are talking about from 2 to 5, which if you notice, that's the in-between part here, which makes sense, right? If you think about oops, I don't know why I made it E. Hold on. 2 to 5. It makes sense that if these are the two sections of increasing and you're looking for where it's decreasing, I wonder if it's in between them. And so sometimes it's a yes, and sometimes it's actually a no, because in between I could be leveling off, right? It could be going straight across. Like the energy level for this one, it wouldn't be changing, but time is still going, right? Okay, a maximum. Where's my maximum? Where's the maximum? So I'm looking for the biggest number. And you're like, Miss Johnson, the biggest number is 30. Good. So people write it like this. You can write it as a point. So you'd write why does this keep doing this? So funny. 2 comma 30. Sorry, 30. Right? Some people actually write it, my maximum is at 30 when X is 2. I like writing it as a point because that's what it is in my head. So minimum, where's the minimum? So I'm looking for the smallest number. So it's right there at 15. So my minimum is at 5 comma 15. Right? So when we're talking about features of functions, we're talking about intervals of increase. We're talking about intervals of decrease. We're talking about our maximums, our minimums, our domain, all of these kinds of things. Hopefully that makes sense.